Hello students, welcome to DEY'S learning. Our today's lesson is a part of name reaction series. Our today's name reaction is Hunsdiecker-Borodin reaction और इसको Borodine Hunsdiecker reaction भी कहते हैं. Okay, let's start. Our starting material is silver salt of carboxylic acid or RCOOAG. This is known as silver carboxylate. Silver carboxylate. If this silver carboxylate is treated with bromine in carbon tetrachloride medium, CCl4 medium, and reflux it, our product will be RBr. This is our alkyl bromide. With the expulsion of carbon dioxide, with the evolution of carbon dioxide gas, and silver bromide will be precipitated. Okay, so this is the method of preparation of alkyl bromide or alkyl halide. This is an alkyl halide. Alkyl halide from a silver carboxylate, that is a silver salt of carboxylic acid. So obviously this is a step down reaction. This is a step down reaction. Step down reaction because this carbon dioxide molecule, this carbon is evolved as carbon dioxide by decarboxylation process. So this alkyl halide contains one carbon less than the carboxylic acid, than the silver carboxylate. So carboxylic acid से alkyl halide तैयार करने के लिए इस रिएक्शन को इस्तेमाल किया जाता है. So but remind it, the alkyl halide contains one carbon less than the starting carboxylic acid or silver carboxylate. Now the first question is how this silver carboxylate can be prepared. This silver carboxylate can be prepared from obviously carboxylic acid, and on treatment of this carboxylic acid by say aqueous potassium hydroxide or maybe any alkaline medium, maybe sodium carbonate, maybe ammonium hydroxide also. And secondly, if we treat it by aqueous silver nitrate solution, you will get the silver carboxylate, and this silver carboxylate on reaction with bromine in carbon tetrachloride medium gives you the alkyl halide or alkyl bromide. So first of all हमें इस रिएक्शन को mechanism देख लेते हैं. Let's look at the mechanism of the reaction. Now our starting material is silver carboxylate, that is this molecule. Obviously this is carboxylate ion, it is Ag+, and in presence of this salt the bromine molecule is somewhat polarized So for example, some del positive charge is developed here, and obviously some del negative charge is developed here due to like dipole induced dipole like interactions. So this O minus charge will attack at the bromine positive center, and this Br minus will be leave from here. So we will get RC double bond O and bromine here. Okay, plus silver bromide will be precipitated from here. Silver bromide. Now this intermediate, this one is known as acyl hypohalite. Acyl hypohalite. We know RCO, this is your acyl group, and we know OX minus, this one is known as hypohalite ion. So for example, OBr minus, OCl minus, etc. OI minus. This one is known as hyperbromite, this one is known as hypochlorite, and obviously this one is known as hypohalite. So now this bond is very unstable. Look at here, this is a covalent bond, and this is the covalent bond between two nonmetals and two electronegative elements, definitely. And obviously oxygen contains 2 lone pairs over there, and the bromine contains 3 lone pairs over there. So there will be some lone pair repulsion, and due to this sort of repulsion, this bond becomes very weak, and this bond can easily be cleaved in the non-polar medium. The reaction occurs in carbon tetrachloride, non-polar medium, and in the non-polar medium the bond cleaved by homolytic cleavage. This one is homolytic cleavage. So as a result of that, we will get this dot and 2 lone pairs over there, this one, and this Br minus and this Br dot becomes free. Okay, in the next step, so we can write this step, this one is actually homolytic cleavage, homolytic fission. In the next step, the decarboxylation occurs. In the next step, decarboxylation occurs due to the fact that this odd electron is donated here, and by breaking this bond, 1 electron will go there and 1 will go here, will come here. As a result of that, we will get the R dot free radical, and with the evolution of carbon dioxide molecule. And obviously this process of evolution of carbon dioxide is known as the decarboxylation. Can you find any similarity of this reaction with other reaction? This reaction looks like Kolbe electrolytic synthesis, isn't it? In the Kolbe electrolysis process, we have seen just like this step. The carboxylate ion remove the electrons, and this free radical will be obtained, and this free radical on decarboxylation produces Dr dot. Okay, and on dimerization of this free radical, we will get the alkane product, or alkene or alkyne product. Okay, now comes back to our present problem. Now this R dot reacts with the acyl hypohalite like RC double bond O bear. I have already told that this bond is very weak, so this R dot will take the bear dot from here and O dot will be formed from here. As a result, we get R bear. This is our alkyl halide, alkyl bromide. This is our final product, and with it the carboxylate free radical will be formed, which will participate in the further reaction. Okay, this is the mechanism of the reaction. You can take a screenshot from here. Okay, let's see some experimental evidences in support of this mechanism. There are many experimental evidences are there which supports this mechanism. So we consider the experimental evidences or only evidences. Number one is with the product alkyl halide, there is sufficient amount of alkane product, alkane byproduct is obtained. So this result supports the formation of this alkyl free radical, because this alkyl free radical on dimerization produces this alkyl free radical this alkane byproduct. Next one is if we take a chiral molecule, chiral carboxylic acid molecule like this one, say this one, R1 COOAG, and this one is this one is R2 and this one is R3. If R1, R2 and R3 are different, then this center will of course be a chiral center, and on treatment of this molecule in presence of bromine in CCl4 medium gives us this product like R1C, and then it is your bromine, and this one is R2 and this one is R3, and of course with it this product will also be obtained. R1, this one is R2, this one is R3. So we will get a mixture of bromine is red, this bromine is also red. Okay, so we will get a mixture of two products, and obviously this will be a racemic mixture. So this evidences, so actually if the chiral center, if the configuration of chiral center be R, then obviously this one will be a mixture of R and S. So the asymmetry is lost there. This can be happen only if this free radical is formed, because we know free radical is planar. So the addition of the Br dot occurs from either side of the plane. As a result of that, we get a mixture of products. So the mixture of products can only be formed if this free radical is formed. So in the reaction, the asymmetry is lost. I can write here. In the reaction, the asymmetry is lost. This is another experimental evidence to support the free radical mechanism. Okay, there are many evidences also. Number 3, I can drop this one. Number 3 is, if we take a pentyl carboxylic acid, neopentyl carboxylic acid, like this one. If we take the neopentyl carboxylic acid salt like this one, if we take this one and on treatment of this compound by bromine in CCl4, we will get the product, this one. CH2Br over there. And the formation of this product from here is possible only if the reaction passes through the free radical mechanism, because if there will be any carbocation like this one, if there will be any carbocation like, if there would be any carbocation like this one, there will be a methyl shift. So this product would not be obtained if the reaction passes through a carbocation. So no carbocation is formed here. Carbocation doesn't formed here. Carbocation is not formed here. The reaction passes through the free radical. This is your evidence. So we can write the neopentyl group doesn't rearrange. So this evidence, so this is a very strong evidence in support of the free radical mechanism. There are many scopes of Hunsdiecker-Borodin reaction. Like if we treat the silver carboxylate molecule in presence of iodine in carbon tetrachloride or ether medium and reflux. Now our product will be RCOOR plus 2 silver iodide will be precipitated down and 1 carbon dioxide molecule will be evolved. So to balance this one, we have to write 2 here. If we take bromine here, we will get the alkyl halide RBr. But if we take iodine in instead of bromine, our product is an ester. The fact is that actually the alkyl iodide molecule is formed from here as usual, but in the next step another molecule of silver carboxylate reacts with this alkyl halide. This O minus attacks here because this is a positive center, this one is negative center. I minus will be leave the substrate, will leave the substrate. As a result, we get this ester. So why this reaction occurs? Because we know this carbon iodine bond is very weak. We can compare the carbon chlorine bond or carbon bromine bond or carbon iodine bond. Of course, carbon iodine bond is very weak. So I minus leaves the substrate very easily, and this weak nucleophile can leave out I minus from here. As a result, we get an ester. So if we treat the silver carboxylate by iodine in spite of bromine, we will get the ester product. So this is an unusual type of Borodine Hunsdiecker reaction. The reaction is actually known as Birnbaum-Simonini reaction. This one is known as Birnbaum-Simonini reaction or only Simonini reaction. This is a special type of Borodine Hunsdiecker reaction. Okay. We can say I have told the formation of alkyl bromide, and now alkyl iodide or ester will be formed. Now what will happen if chlorine is added? If we take chlorine, if we subject to react chlorine with this molecule, obviously this product will be obtained, but this is a very low yield product. This is a very low yield product, because we know the chlorine bond energy is, this chlorine bond energy is sufficiently high. The order of bond energy, I can write here, the order of bond energy, of halogen molecules is Cl2 is greater than Br2 is greater than F2 is greater than I2. Of course, due to the lone pair repulsion and the smaller distance between two fluorine atoms, its bond energy is very low. So the bond energy of chlorine molecule is very high. So it is very difficult to form to break this bond. So the formation of acyl hypochlorite, this one is not easy. So this one is a very low yield product, very low yield reaction. So I have told the reaction of bromine, iodine, and next with chlorine. Fluorine doesn't participate in this reaction. Now let's see the modification of Hunsdiecker-Borodin reaction. The modification is known as Kristall-Firth modification. The modification is known as Kristall-Firth. Again, the name of two scientists. Kristall-Firth modification. This is the modification of Kristall-Firth of Borodine Hunsdiecker reaction. Two scientists said that if we take the carboxylic acid molecule like this one, and if we treat this molecule by bromine in presence of mercuric oxide HCO in CCl4 medium, we will get the same product as R beer plus HgBr2 mercury bromide and carbon dioxide evolution will occur. So this reaction is known as crystal fourth modification of Borodine Hunsdiecker reaction. So how this reaction occurs? We know mercuric oxide, this one is a basic oxide, and on reaction of this basic oxide with this carboxylic acid, we will get this type of product, that is mercuric acetate. And this mercuric acetate on treatment with bromine gives you RCOOBr, and obviously this one subsequently form the product RBr. So this is again nothing but Borodine Hunsdiecker reaction, modified Borodine Hunsdiecker reaction. Only mercuric oxide is used here instead of the silver salt of carboxylic acid. Let us consider some examples of Borodine Hunsdiecker reactions. The examples, or we can write some applications. Applications. Number one, if we have this type of intermediate, this type of substrate, on reaction of this compound by silver oxide Ag2O and then bromine in CCl4 medium, the product will be obviously silver carboxylate will be formed and bromine will be substitute this portion. As a result of that, we get this compound, cyclobutyl bromide. Okay. The next example, if we have the molecule like this one, this one is 4-nitrobenzoic acid or para-nitrobenzoic acid. Para-nitrobenzoic acid on treatment of this molecule by number one is hot aqueous sodium carbonate, and then by aqueous sulfur nitrate gives us the silver carboxylate salt COOH and nitro here, and on treatment of this molecule by bromine in carbon tetrachloride medium gives you this one, that is para-nitrobromobenzene. This is your 4-nitrobromobenzene. So This compound can be prepared by using Hunsdiecker-Borodin reaction. Our next example is number 3. If we have this molecule and on treatment of this molecule by mercuric oxide and bromine in presence of CCl4 medium, gives you the product cyclopropyl bromide. Number 4, if we take the large chain molecule like this one, and on treatment of this molecule by mercuric oxide in presence of bromine and CCl4, you will get in C17H35 bromine. So this is another example of Borodine Hunsdiecker. Now you can take a screenshot from here. In the next example, number 5, if we have the bridged compound like this one, if you treat this molecule by bromine in CCl4 medium, you will get the product like this one. Okay, next one, if you take this molecule, this one is 2-phenyl acetic acid, 2-phenyl acetic acid, of course the silver salt of 2-phenyl acetic acid. If you treat this molecule by bromine in CCl4 medium, you will get the product like this one. No, if we treat this product by iodine in say CCl4 maybe ether medium, you will get a ester, an ester like CH2, then CO, then O, then CH2, then benzene. This one, isn't it? This is your product. If iodine is present, the ester will be formed. The ester will be formed from here. This one is COO minus attacks. This one is minus, and iodine will be formed here. So O minus will attack here, the nucleophilic attack, and I minus will leave the substrate. You will get this one. The name of the molecule is, this portion is benzyl. So this one is benzyl 2-phenyl acetate. 2-phenyl acetate molecule. So this one again I can write here. This one again is Simonini reaction. Simonini reaction. In the next example, consider the molecule 1 2 3 4 1 2 3 4 CHH. This one is a 6 carbon dicarboxylic acid. This one is known as obviously adipic acid. This one is adipic acid. If we treat this molecule by number 1 aqueous potassium hydroxide, next aqueous silver nitrate, we will get the silver salt AgCOC 1 2 3 4, then COAG, and on treatment of this molecule by bromine in carbon tetrachloride medium gives us bromine here 1 2 3 4 and bromine here. This molecule is 1,4-dibromobutane. 1,4-dibromobutane. Dibromobutane. Okay. Proceed to our next problem. Our next problem is like number 6, problem number 8. If we have the molecule like this one, AgCOC 1 2 carbons, then CH, a methyl maybe over here, and COAG 1 2 3 4 5 6. Okay. If we treat this molecule by iodine in ether medium or maybe CCl4 medium, what will happen? This molecule by iodine in presence of CCl4 medium, iodine will be here. I can write here I. This one will be your intermediate CH3COAG, and this one will be the intermediate, and this minus attacks here, I minus will leave. As a result of that, you will get this product. I can write here O, then CO, 1 2 3 4 5-membered ring will be formed. 5-membered ring will be formed here, C double bond O. Next carbon, this one is methyl, contains methyl, and then 2 carbons, then oxygen. So this one is again an ester, of course ester, and this one is actually cyclic ester, and cyclic ester को lactone कहते हैं. We know that this one is lactone, or sometimes it is called alpha, beta, gamma. So it is your gamma lactone. So this one is actually a gamma lactone. This one is actually gamma lactone. So obviously this one is again Simonini reaction, the modified form of Hunsdiecker-Borodin reaction, Simonini reaction. This is all about Borodine Hunsdiecker reaction. We will meet with some another important video. तब तक के लिए bye bye.